Hey guys, today I'm here to present my topic for my digital assignment 3, that is Advanced Encryption System, that is AES algorithm. AES algorithm is a really widely used encryption algorithm. It was considered as a standard for encryption algorithm in the past. So let's get into it, and I'll explain about what AES is and how it works in the further slides. So, advanced encryption standard is a specific encryption electronic algorithm. So, what does AES basically? So, initially, DES was the symmetric algorithm that was used worldwide for encryption. What DES is like data encryption system or standard. So, data encryption standard was used in its earlier time, and but the thing was like it was really easy to crack. Then came triple DES. Triple DES was triple data encryption standard. So triple data encryption standard was tough to crack, but it was really computation intensive. So that's why AES emerged. AES is advanced encryption standard. So advanced encryption standard was much more faster and was computationally as well as timely faster. So that's why it was accepted as an universal standard in various places. So why is AES so fast? So it uses substitution and permutation for its for its computation, and that is ciphering. A single key is used that's extended more and more in its further rounds, which makes it difficult to crack. And AES performs it performs encryption on 1 byte rather than a bit, so which it makes the computation really fast. And also the number of rounds is dependent on the key length. So you can also have various rounds of encryption based on the size of the key. So if you have more computational power, it ensures more security. So there are 3 bits in which it works. First is 128 bit, then it works on 192 bit and 256 bit. It also the number of rounds also depends, like 10 rounds for 128 bit, 12 rounds for 192 bit, and 256 bits has 24 rounds. So that's how it works. The AES history, as it was a variant of reasonable block cipher. We'll see how reasonable block cipher gets involved into AES in the further slides. As I said, it was replaced for triple DES in 1977, and then AES was used as a single key encryption algorithm. It's a symmetric encryption algorithm. So how AES works? So these are the steps of what AES works. This is just an overview. I'll give the detailed step in the further part of the slide. Round key algorithm was derived from cipher key. It was used in used to schedule the what is it called, like first was the key expansion part. So if you have a key and the key is expanded based on the number of rounds the algorithm is going through. Each and every time a new round key is being updated to your key, and that key will be used to cipher your text. So hence it will ensure your ciphering to be more tough to crack. Then initial round key addition, that is at the start stage, that is in the first round, the normal key will be added based on an XOR operation with your actual text, and then the rounds will be carried on. Then we have the round till round 9, 11 or 13 rounds based on the size of your key. As I said that 10 bytes for 128, 192 has 12 rounds, and 256 bits has 14 rounds. So 9, 11 and 13 is n minus 1 round. So till n minus 1 rounds, I perform the following operation. First is the sub bytes operation. Then I have the shift rows operation. Then I have the mixed columns. Then I have the round key operation. Then I have the final round operation. So this is how each and every operation works. And then I have the final round, that is the nth round. The sub bytes operation, shift row operation, and add row key operation is done, and mix column is not done at that point. Yeah, so now let me take you into the topic and explain how the actual working of AES algorithm is. So before we get into the actual implementation, let me run you through the use cases of AES. So AES was used in various encryption algorithms for sensitive data. So whenever you wanted to send the sensitive data across the internet or the network, we used AES algorithm because it was a basic standard at that time. So it was used to encrypt data and send to the internet. It was replaced over DES because on performing brute force, AES was DES was easily vulnerable. So AES was used and it was difficult to go through brute force. So that's why AES algorithm was used worldwide. Then it was accepted as a national standard, and for each and everywhere where encryption was required, AES was being used. So even in today's day world, AES is being used as an encryption algorithm in various platforms. So this is about the use case of AES algorithm. So this is the overview of how AES algorithm works. So there's a plain text, and yeah, they have missed one part here. Just give me a second. Use a pen. Yeah, so I guess now I'll be able to use my pen. Yeah, so there's a plain text, and before it enters, I actually perform an XOR operation with my initial key, that is my secret key. So this operation requires a secret key at the initial stage. So now the XOR operation secret key text is passed into your round one. Round one is basically sub byte, shift rows, mix rows, and added round key. So this takes place for n minus one. I'll explain each and every part in detail in the next slide. So this takes place for n minus one times based on the size of your plain text. So after that, after n minus one times, yeah, each and every time the cipher key gets updated based on the round. So that key is used in these steps again and again, and at last the cipher key, the last round key is sent to the last round, and here except the mix columns, all other operations are being done, and at last you get the cipher text as an output. So this is how the algorithm works in an overview. But let me give a deep explanation of how each and every algorithm works in the next slide. So let's have plain text. Yeah. So this plain text is first performed with an XOR operation. This plain text plus my with my secret key. Yeah. So my secret key and the plain text go through an XOR operation. Yeah. And my secret key can be of varying size. So this is an XOR operation, that is a plus and a circle. So my secret key can be of varied size, as I mentioned before. It can be 128 bits. Then it can be of 192 bits, if I'm not wrong with the number. Then it can be of a 256 bit. Sorry about that. So it can be a 256 bit key. So based on this size, the number of rounds that will be performed is decided. So this will be 10 rounds. This will be 10 rounds, and this will be 12 rounds, and this will be 14 rounds. So the number of rounds will be decided based on each type of key. Now, after I get the output, I'll enter my n minus one rounds for operation. So n minus one rounds first as sub bytes, and then I have shift rows. Then I have my mix column. Okay, and I have my add round. I'll add my round key here. Round key is basically the each key used in each and every round. And then this operation will be performed for n minus 1 times. So what each and every operation inside each round means. So that I'll explain it right now. So let's start with the first operation, that is sub byte. So the type of text we get is represented into an matrix. It's a 4 into 4 matrix. So and each key in the matrix will have 1 byte. Each will have 1 byte, and hence we'll have a 16 byte matrix. Yeah, and we also have another matrix, say the key matrix. This is a private key. This matrix is not required in this step, but I'll just introduce you to this. So this is called the key matrix. So the key matrix is used for deciphering the key matrix is used as an input for starting the deciphering. This will be so at the initial step before sub byte, an XOR operation is performed, and we get a new matrix that will be used for calculations in the further round. So what is sub byte here? What does this sub byte operation actually do? So sub byte operation deals with S box. So let's say I have an 1 byte, let's say 19 in this block. So my sub byte will have an S box or an lookup table. That lookup table is called sub box. That lookup table is also available in Wikipedia. So the first row and ninth column of the lookup table will be checked, and that element will be replaced with 19 inside my box that I get after XOR. And similarly, each and every element inside the 16 into 4 into 4 matrix is replaced with the lookup table elements, and hence we have a final table after subbyte. So after subbyte, we go to the next operation, that is the shift rows. So what shift rows basically does is, like, I have a matrix. Let's say, oh, sorry about that. So I have a matrix, 4 into 4 matrix. So I'll just replace my number of rows here. I'll replace this row with here. Like, I'll just add it circularly here. I'll replace the last two rows of this into the last position. I'll insert it here, and then I'll have 3 rows inserted at this point. So the final row, let's say it was A, B, C, D, E, F, G, H. So my final output will be A, B, C, D, F, G, H, and E. And similarly, other two. In the second case, 2 elements will be inserted here, and the last case, 3 elements will be inserted here. So that will be my final output. And then I have my mixed column row. So what is my mixed column row does is that it multiplies each row. Let's say I have my output from the shift rows operation. Yes. So it takes this row, it multiplies it with a matrix that is given to me based on the Rindle algorithm, and that matrix is given to us by the algorithm, and then it is multiplied with this row, and this row is it also is a 16 by 16 matrix, like 4 by 4 matrix. So this the result that we obtain is like, because like it's 1 into 4, and this is a 4 into 4 matrix. So the result we'll obtain is a 1 into 4 matrix, and that matrix is being replaced with the row we get is replaced with the current row inside the actual matrix we get, and hence the same operation is performed in each and every row inside the obtained matrix, and hence we have a final matrix that will obtain, that is also a 4 into 4 matrix, and that will be passed on to the last step, that is the add round key operation. So what happens in add round key operation is just simple. We have the round key, and initial step, the round key is the first key that we have, the normal key, and yeah. So we have the message that comes from the mixed column, and then we have the round key. So each and every row here is picked up, like each and every row here is picked up, and each every element inside the row, let's say this element, and this is my secret key. So this element and this element, an XOR operation is performed, and the final matrix is derived, that will be passed on to the next round, and hence the same happens with each and every element in the matrix. Yeah. So each and every element in the matrix gets the same element, and as I also get a new key as an output based on certain operations on the secret key. So this is called my round key. So this round key will be used inside my next round for add round key operation. So hence the round key also is getting updated, and my message is also getting updated. After n minus 1 round, the same three operation is performed in the nth round, and except the mixed column operation, and hence the last output will be my ciphertext. So after going through these many rounds, the ciphertext is really tough to crack and requires a lot of computation to crack it. So that's why AES algorithm was considered to be really efficient in creating ciphertext. So let's get into the advantages. It was really time efficient among the symmetric algorithms for encryption. Tested and corrected algorithm as well. It went through various tests, as you know, it's a really old algorithm, and computationally fast and symmetric among the algorithm, that among the symmetric algorithm. So in talking about asymmetric, I've also posted a video regarding that for my digital assignment too, that I worked on, that is on ECDSA. So you can also check out that video for asymmetric algorithm, that's more faster and more efficient than AES. But AES as a single key algorithm is efficient within the domain of single key or symmetric algorithms. So there are certain flaws in AES as well. It was too simple in algebraic structure, though it's a long process and it's computationally intensive. It is not algebraically tough. So the algorithm to break the algorithm, only computational power was the breakage. But in today's day, computational power has grown to really high end. So breaking this algorithm is really easy. And if you see, the method of encrypting is quite repetitive, that it is being repeated on a regular basis. So that was also a major setback for AES, like the subbytes, shift rows, mixed columns, and add round key operation is done continuously again and again. So that makes it really easy to predict how the algorithm is working. And if you want to implement this algorithm with software, it really becomes difficult to integrate both of them together, because it is time consuming and the software response should be really fast. So that makes it really tough to work with it. And in counter mode, it is really complex to India. As I said, it's really complex to work with softwares to consider performance as a performance and security in its view. So that's why these are the flaws in AES. So that's all about AES, and I hope that the seminar was really interesting. Thank you so much for spending some time with AES. years.